what does it mean for tool providers like Synopsys and for the EDA industry in general?
Okay. I think part of our role, as I mentioned, is to provide advanced tools that allow people to do these interesting designs and have differentiation in their products. Let me give you one example. I mentioned already routing technology because you can save layers, that's cost, but also opens other possibilities. But let's look at low power, for example. Everybody is very concerned with super low power for a smartphone, for a tablet, and so on. But let's look at healthcare. The world population is aging, and 2 years ago, I believe, we had at our event for Place and Route at the Design Automation Conference, a Danish company called Oticon, that is a provider of super advanced hearing aids.
Okay.
Obviously, we'll all need hearing aids if we keep going the way that we're going as we age. But it was very interesting for them. They presented a chip done using, at that time, our most advanced synthesis, our most advanced Place and Route. It was a 65 nanometer chip, but they needed to get super low power because battery life for them was, what makes one of the parameters that makes that different. So low power, for example, enabling EDA, enabling the techniques that designers use. Well, I saw an example of a chip at 180 nanometers that had 12 voltage regions.
Oh, wow. Okay.
You say 12 volt at 180 nanometers, what could be difficult there? I don't think that you could have designed that chip with the tool set that we were providing to our customers at the time that 180 nanometers was the latest technology. So low power is very clearly one of the areas that we can do better. But there are other areas, for example, the interaction between digital and analog. And that's also one of the reasons we have a new group. If you take a look at any of these types of chips, there is usually some sensors, some analog parts, some communication pieces there. And that's an area where the interactions between the digital side of the design and the analog have never been the best. If you take a look at what we did with Custom Designer and the custom router and IC compiler in terms of data transfers and all that, we offer a tremendous plus to people to be able to complete signals that were very critical and all that. So that's another area, for example, that is quite important for us. And I could give many others, but I think that gives you a flavor. For example, you mentioned in these types of designs, cost is a very high consideration. And I'm glad that you mentioned area, because in our efforts in logic synthesis, if you look at what we have done in the last few years, we put like a piece of the placement there, much better estimation for wiring. But in reality, what we were working on there is the piece of trying to predict timing across the flow. And, you put a big effort there. And today, we're back to what I call some basics. Can you make this block a little bit smaller? Because reducing that means, I could put something else on the chip, or I could reduce the cost. So we have a big initiative between Design Compiler mostly and a little bit on IC Compiler to make sure that we can attack back, these types of basic variables. It's always like we go in one direction, and a few years later we go back to look at that. So that's another. If you take at prime time, for example, more corners and all that, the level of reliability that people want to check, if you look at automotive chips, a failure on an ABS can be much more serious than a failure or that you drop a call on your cell phone and all that. So all those are pieces where we're engaged trying to give people the EDA tools that they need to do this.
Makes a lot of sense.